Hi everyone, in today's video we're going to be going over question 1 of the 2023 Calculus BC exam. So first, let's read the question. A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. Part A is asking us to interpret the meaning of the integral from 60 to 135 of f of t dt in the context of the problem. So we know that f of t is a rate, and it's a rate at which gasoline is pumped in to a gas tank in gallons per second. So if we integrate a rate, it's going to give us the accumulation in that time interval. So this tells us how many gallons of gasoline were pumped in the tank from times 60 to time 135. The rest of question A is asking us to use a Wright-Riemann sum with the three subintervals 60 to 90, 90 to 120, and 120 to 135 to approximate the given integral. So we know that the difference between 60 to 90, 90 to 120, and 120 to 135 are not all the same. So when we're going to do R sub 3, we're going to do each interval separately. So we know that the difference of 60 to 90 is 30, and f of 90 is 0.15 gallons, plus the difference of 90 to 120, which is 30, and f of 120 is 0.1 gallons, and the difference of 120 to 135 is 15, and f of 135 is 0.05 gallons. And this is going to give us 8.25 gallons, which means that in the time interval of 60 to 135, approximately 8.25 gallons were pumped into the tank. Part B is asking us to prove the statement, must there exist a value of c, for c being between 60 and 120, such that f prime of c is equal to 0. Justify your answer. So, because it's asking us to see if there's a value for f prime of c, and that value is 0, between two numbers 60 and 120, this implies that we need to use mean value theorem. The condition for mean value theorem is that our function is differentiable. And it does state right here that f is a differentiable function, so we can use MVT. So using MVT, we will do f of 120 minus f of 60 divided by 120 minus 60. And we know f of 120 and f of 60 are equal, so the top will equal to 0, and the bottom will equal to 60, which is 0. So this tells us that there must be some c because f is differentiable. I'm going to abbreviate it. There must be some c between 60 and 120 such that f prime of c is equal to 0 according to mean value theorem. Part C is asking us, the rate of flow of gasoline in gallons per second can also be modeled by g of t for t between 0 to 150. Using this model, find the average rate of flow of gasoline over the time interval 0 to 150 and show the setup for your calculations. So because this is a calculator active problem, in your graphing calculator, you can set g of t equal to this function given and use the average value function, which is 1 over b minus a, integral of a to b of, in this case, g of t dt. Our a and b is 0 to 150, so our setup will be 1 over 150 integral from 0 to 150 of g of t dt. And plugging this into our calculator will give us 0.0959, or you can round it as 0.096. And the unit is going to be gallons per second because we're finding the average rate of flow. So lastly, part D is asking to use the model of G defined in part C to find the value of G prime of 140. Interpret the meaning of the answer in the context of the problem. So once again, this is calculator active. So if we previously have G of t saved in our graphing calculator, all we have to do is take G prime of 140, and our calculator should give us negative 0.0049. And because this is a rate of our rate, it's going to be gallons per second, or you can write it as gallons per second squared. And the meaning of our answer is that at time 140 seconds, the rate at which gasoline is poured in the tank is decreasing at a rate of 0.0049 gallons per second squared. And it's decreasing because G prime of 140 was negative, so keep that in mind when writing your answer. Thank you so much for watching. I hope this video helped with the first question, and our next video will go over question 2.